Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is deep soil mixing. So here, according to these type of ground improvement technique, what we are understanding. So in this particular case study, so what we are understanding is that the deep soil mixing is one of the technique which we are used in ground improvement techniques. As a part of ground improvement techniques, for choosing these deep soil mixing is depends upon the what type of project it is. In that particular project, according to the type of project, we are going to choose the method or technique for getting the desired properties. So what are there we will see in this particular case study. So in this case study, what we are understanding is first we have to know about the deep soil mixing, where we are using what kind of soil types. So type of soil, according to the type of soil, once we understand this, we have to know about the soil properties. Those soil properties are suitable or not for the required project, or what kind of structural elements are suitable or not, we are going to understand in this particular topic. So in this case studies, what we understand that is, in this deep soil mixing, it is a ground improvement method that involves blending in situ soils with cementitious or other binder materials to increase the soil strength and reduce compressibility. Whenever the soil properties are there, those soil properties strength is not enough for done the desired construction work, for required construction work, for getting the desired properties of that particular soil, we are choosing these kind of deep soil mixing. So here in this we are going to use, here once we done this technique, so after that we know we are getting the increase the soil strength and also reduce the compressibility. Whenever these kind of soil strength and compressibility whenever these soil strength and the compressibility of the soil, so where these kind of scenarios we are going to observe in soft soils. So in that particular locality, what kind of nature of the soil is there? We know collect the samples and understand the all kind of properties for conducting the lab tests, whether they are laboratory experiments, using laboratory experiments and equipment, find out the properties. In situ laboratory tests also we are going to conduct it using some equipment. So like that we are going to understand the overall soil condition, and as per the design, as per the project, what kind of project we are doing. So as per the project, we are going to understand whether the soil conditions are suitable or not. Once they are not suitable, we require these ground improvement technique. Ground improvement technique. So in this ground improvement technique, So one is deep soil mixing. Once we choose, it means it is suitable, and we required the project, that is we required the, so increases the soil strength and also reduces the compressibility. These are all the parameters which are involved in this particular deep soil mixing. So moving to this definition, we are going to choose, we are blending in the in situ soils on site. What kind of soil is available, we are going to blending with cementitious and other binder materials. This is nothing but the deep soil mixing. This has so many different parameters are involved for this cementitious. What kind of material we are using for binding also plays a major role in this deep soil mixing. So it is depend upon the what kind of soil characteristics are required is plays a crucial role for identifying the which type of blender we are going to choose for this deep soil mixing. So here we are going to understand. Once we understand and we choose the deep soil mixing is nothing but the DSM process. So in this DSM process, the equipment what we choose, that is specialized rotating tools, are used to mix the soil and blender. So in this binder, what kind of binders are there? Different types of materials are there. So we may use cement, various types of aggregates, and soil superplasticizers. So it is depends upon the water conditions also, and it depends upon the how much the plasticity it is there in the soil, and how compressibility and the stability point of view and bearing capacity point of view, bearing capacity of the soil, stability of the soil, compressibility of the soil, overall soil strength of the particular soil. And for construction, were there the required construction, what strength is required, how the soil strength is there, how much we require for construction of the project. These are the things are plays a role, what type of bender we are going to consider. Cementitious materials, they may harmful in environmental point of view. These are all the parameters we are going to involve in this. All these parameters involved in this particular conditions. So here we are used this deep soil mixing process, that is nothing but the DSM process. Here the equipment what we used for these specialized rotating tools are used to mix the soil and the binder. And also these tools are mounted on drills or augers that penetrate deep into the ground. We don't know how much depth that is required. So as per that we are choosing the equipment, and the penetration is there for this into the ground for the required depth of the thing. In binder selection, the binder typically consists of cement or mix of cement, other additives such as lime or slag, chosen based on the soil conditions. According to the soil conditions, we are going to choose what kind of material for this binding, for in which parameter is going to enhance or which parameter is going to improve, or modification is required in which type of parameter. These are the parameters, these are the things we are going to consider for choosing the binder, whether it is mix of cement and other additives such as lime, slag. So these are the parameters. So what kind of that mixer, whether it is lime or slag, how, in which characteristic point of view it is going to give the enhancements to the soil. So in this we choose, after that based on the characteristic requirement of the soil for getting the for withstand of the project or based on the project requirement. So we are going to choose here some of the steps those are involved in deep soil mixing. So in this drilling, a hollow mixing tool is drilled into the soil to the required depth. So here we are going to provide hollow mixing tool. It is drilled into the soil to the required depth. And injection, the binder material is injected into the soil through the mixing tool. So in this we choose this mixing. The rotating mixing blend the binder with the surrounding soil. So creating columns of treated soil with enhanced strength. So once the mixing is done with these blades, it is going to blend with surrounding soil. So it created columns of treated soil with enhanced strength. And also cement means and other additives also they required some curing time. So that is also part of these deep soil mixing. So here the curing over time, the binder chemically reacts with soil, hardening and forming stronger columns that stabilize the ground. So for stability also is one of the parameter in these kind of deep soil mixing. So according to the strength point of view, hardening of the soil and also the compressibility, it increases the, whenever it is highly compressible, it is reduces that compressible nature of the soil, and also the stabilization. These are the parameters which are going to involved in this particular conditions. So here we are going to understand in this DSM. So here what we understand in this previous slides, according to the type of project, the soil conditions are not suitable. The existing soil conditions are not suitable. We are choosing these one of the technique that is equal to deep soil mixing, that is nothing but the DSM. The process involved is like this. So in this drilling, injection, mixing and curing we are doing as a part of this deep soil mixing. In this, different types of mechanism of these deep soil mixing is involved. We will see in this particular slide, that is soil stabilization, column formation, improved drainage. So here these are the some of the mechanisms which are involved in this particular technique which we choose. So in this soil stabilization, the added binder reacts with soil particles, filling voids and binding particles together. This chemical reaction, whenever we are filling with these binders, as whether they are cement or other materials like lime, slag, etc., we are choose. So they are creating some chemical reactions with the soils. And also we may choose two different binders also. The addition of that also creating some chemical reaction. It improves. Finally, the chemical reaction, they are helpful for improving the soil properties in terms of strength point of view and also compressibility point of view. The compression strength is increases and reduces the compressibility. So the reduction compressibility gives the better soil properties for suitable for the towards suitability for the construction works. So and one more that thing, so this is the one of the parameter which is we get for these whenever those soft kind of soils we are choose these kind of techniques we are choosing. In column formation, so the deep soil mixing forms columns. So because of the whenever we are choosing this equipment and also we are bending with this soil, so it creating those kind of columns. So treated soil that act as load bearing structures, transferring loads from the heavy embankment to deeper, more stable soil layers. So because of these column formation, we are getting the stable soil, which means it is going to create the stable soil layers for into the deeper depth whenever the deeper conditions. So it is helpful for transferring the loads from highway embankment to deeper conditions, and also The load bearing capacity is also the soil that act as the load bearing structures also. So this column formation mechanism is also involved in this deep soil mixing. And moving to the improved drainage system, the cement treated soil also become less permeable because of the these kind of soft soil nature. It means the adaptability of the water is there. They are going to adopt the water into them, so that creates so much of uh, erosion point of view, and also it is harmful. It may lead to the structural failures. Without using any ground improvement technique in such type of soils, we may construct any type of project or any type of constructions work we are going to done without these ground improvement techniques. It may lead to the structural failure. So in those conditions we are going to allot, and these cement treated soil also become less permeable, reducing water infiltration and helping control consolidation settlement. So here also this helping control consolidation settlement gives the enhancement to the whenever the project we are choosing for construction work, it is helpful. So this cement treated soil becomes less permeable, reducing the water infiltration. So whenever the soft soil is adopted, once we done with the DSM, deep soil mixing process into it, so once it is involved with the cement and other different types of materials, so the mixing gives the less adaptness of the soil. That means it reduces the water infiltration and helping control consolidation settlement. So these are all the parameters which are involved in this particular case study we are understanding from this deep soil mixing. So in this, the cement treated soil also become less permeable, reducing water infiltration and helping control consolidation settlement. In this, we are using equipment and their techniques. So here the equipment and techniques, mixing tools. So these deep soil mixing rigs use agar type or rotating mixing tools that vary depending on soil conditions and required depth. So we are choosing these mixing tools. It depends upon how much depth the soil mixing is required, how the soil conditions are there, and surroundings and surrounding conditions of the soil. It may be water table, groundwater conditions, and also the nearby structures. These are all the various parameters which are involved in this particular condition, in this particular choosing of the mixing tool. So it depends upon the how much the soil conditions and where the required depth also. The soil conditions are different from whether it is maybe soft soil also. The soil conditions are going to different. It depends upon the place, vary from place to place, and its region to region, that is difference. We have different types of deep soil mixing. Those are wet mixing, dry mixing. This cement slurry is inducted into the soil and mixing is nothing but the wet mixing. And dry cement or lime is mixed with soil in situ without water. Such type of mixing is known as dry mixing. The name itself tells us whether the cement in slurry, it is mixed with some water that is injected into the soil and mixed. So such type of deep soil mixing is nothing but the wet mixing. And dry cement or lime is mixed with the soil in situ without water. The type of is nothing but the dry mixing. This column configuration, and one more we are understanding as a part of this equipment and techniques, this column configuration, because the deep soil mixing is once we are doing the process along with the equipment, along with the binder, they are going to form the columns. So these column configurations, these columns are based on the required ground improvement level. It depends upon the how much depth we required for this process. So till how much depth we are choosing, until up to where that point we are going to choose for as per the soil conditions and also as per the project requirements are involved in this particular point. So once we understand these columns configurations, we have to understand this column spacing also. That is, it depends upon the way, how much depth we are choosing for these arrangements. So they can arrange it in grids or lines or honeycomb patterns, it depending upon the structural road requirements. How we are arranging this column configuration, the spacing, and how much till up to which depth the requirement is there, or we are doing as per the project requirements, and in it is what kind of arrangement, whether it is grid arrangement or line arrangement or honeycomb patterns. So we have different types of patterns, that is depending upon the structural load requirements. So how the structural loads are coming is depends upon the type of the structure, what is there, whether it is, for example, we are same situation, we are choosing these deep soil mixing for bridge construction, foundation works and building constructions, other type of commercial infrastructure are important structure. Same type of construction work we are going to done with different regions. Earthquake affected regions, wind affected regions, and these are all the different types of surrounding atmospheric conditions. Surrounding conditions are different. These are the various factors involved in this choose of the technique. So once we choose, the depending on the structural load requirements is the parameter for arranging the type of the column configuration. So bridge, the load requirements are different. For building, the load requirements are different. So whenever coming loads are different in bridges, so the heavy loads are going to move, the moving loads are there every time, even though the dead weight of the bridge is more, even though the heavy loads are moving, coming to the residential buildings and coming to the heavy structures or any type of industrial construction. So these are the various parameters which are involved in this structural load requirements. Now, so based on this, when we are constructing highway abutment, so this outcome for these deep soil mixing for the highway abutment, once we consider this as our case study, so here improved of the soil strength. So the improved of the soil strength and reduced settlement and also the cost and time efficiency are the parameters which are involved in this outcome, as well as the benefits of the DSM. So here the improved soil strength, increased compressive strength, the deep soil mixing technique increased the compressive strength of the clayey soil, allowing it to support the weight of the highway embankment. In load transfer, the deep soil mixing columns helped distribute the load of the abutment over a large area, reducing the stress on the weak soil and preventing the shear failure. So these are the things we are going to understand in this deep soil mixing under the characteristics of the property of the soil strength point of view. So here it is increased the compressive strength and also the load transformation. And one more thing, that is the reduced settlement. So in this reduced settlement, control of the total settlement by increasing the soil strength and reducing its compressibility, this deep soil mixing minimized the total settlement of the embankment. And reduction in differential settlement, the uniform distribution of treated columns ensured even load bearing capacity, thereby reducing the risk of differential settlement, which is critical in maintaining the structural integrity of the highway. And these reduction in differential settlement is very, very helpful in these this is one of the major benefit from these deep soil mixing in these highway abutment, because of the uniform distribution of treated columns ensured these differential settlement, even load bearing capacity. So thereby the reducing the differential settlement, and which is crucial in maintaining the structural integrity of the highway in this reduction in differential settlement. In long-term stability, the treated soil become more resistant to consolidation and other time-dependent settlement issues. So these are the parameters which we are going to understand. And in terms of cost and time efficiency, cost effective solution compared to the traditional deep foundation techniques like spilling, DSM is more economical, improving weak soil over large areas. So whenever for large areas in weak soils, this deep soil mixing is the suitable one. Suitable technique for getting the desired requirements like strength improvement in terms of soil strength, compressive strength point of view, and also reducing the compressibility, reduce the water infiltration, and also in terms of stability point of view. These are the things which we are going to understand. In large areas point of view, it is advantage. Whenever it comes to the small areas, the cost is more. And the reduction construction time. So the deep soil mixing method allow for the faster construction compared to the preloading or other consolidation methods. So these preloading, they take much time when compared to these kind of deep soil mixing, which often require long waiting periods. So it affect the project time, and various parameters are involved. For delay of the projects also increases the cost. So in that particular point of view, it is faster construction when compared to the other consolidation methods. In these advantages and limitations of these deep soil mixing, so if these deep soil mixing is effective in soft soils, adaptable, minimum environmental impact, and long-term durability. So this deep soil mixing is particularly effective in improving soft clays, silts, and loose sandy soils, making them suitable for heavy structures. These adaptable, the technique can be adapted to different soil conditions and project requirements. Minimal environmental impact. These deep soil mixing causes less distribution to the surrounding environment compared to the excavation or deep filling. In this long-term durability, the soil blender mix remains stable over time, providing a permanent solution to soil weakness issues. These are the advantages which we are going to understand in this deep soil mixing. Coming to the limitations, cost versus traditional ground improvement techniques, although cost compared to the deep foundations. So deep soil mixing can still more expensive than similar techniques like surcharging, dynamic compacts, especially for shallow improvements. Soil variability. Highly variable soil conditions may require additional testing and monitoring to ensure consistent performance. And curing time, depending upon the soil type and binder used. So these DSM treated soil may require a curing period to reach its full strength. And contamination concerns. DSM may not be suitable in areas with contaminated soils due to the risk of the mixing pollutants with binder material. So these are the various parameters which are involved in this particular deep soil mixing limitations. Finally, these kind of DSM mechanism inside in situ soil is strengthened by mixing it with binders, creating load-bearing columns that reduce settlement and increase bearing capacity. The application of these deep soil mixing at Tokyo Highway abutment successfully improved the soil strength and prevented settlement, ensuring the stability and longevity of the structure. So in this, direct shear method is commonly applied in geotechnical engineering and has been utilized in various fields such as building foundations and marine infrastructure. Here are some of the examples we may understand from building foundations. In pile foundations, shallow foundations, retaining walls are there. So in this pile foundations, this deep soil mixing Deep soil mixing is used to assess the shear strength of soil layers during the design of pile foundations. The method helps determine the load bearing capacity of the soil. So, in terms of this characteristic, that is equal to load bearing capacity. So, which is critical for designing the stable pile foundation in multi-store building. In shallow foundations, for shallow foundations like spread footings or mats, this deep soil mixing is employed to calculate the shear strength of the soil of the foundation. This ensures that the foundation can support building's load without experiencing the excessive settlement or failure. Coming to the retaining walls, this deep soil mixing helps in analyzing the shear strength of backfill soil behind retaining walls. This analysis is crucial for ensuring that the soil does not fail, which would cause the retaining wall to collapse. These are the parameters which are involved in this particular building foundation. Moving to the marine infrastructure, these offshore wind turbines and breakwaters and jetties, underwater tunnels are there. So, this deep soil mixing has been used in the design foundations for offshore wind turbines. So, the seabed shear strength must be evaluated to design monopolies or jacket foundations, ensuring stability against lateral forces like wind and waves. These breakwaters and jetties in marine construction, deep soil mixing helps assess the shear strength of seabed soil for breakwater and jetty foundations. The shear strength data assists in designing these structures to resist wave forces and prevent erosion. In underwater tunnels, the project like subsea tunnels, these DSM deep soil mixing is used to analyze the shear strength of the seabed and surrounding soil to ensure that tunneling operations can be conducted safely without risk of collapse. In transportation infrastructure, road and railway embankments, these deep soil mixing helps determine the stability of the soil beneath embankments for roads and railways. This ensures that the embankments can support traffic loads without slipping or failing. In bridge foundations for bridges, this deep soil mixing is used to evaluate the soil's ability to support piers and embankment, especially in soft soils or riverbed conditions. In detail about these building foundations, so the loads, whenever the loads of the structure, they are going to transfer them safely to this soil condition to ensure the foundation can sustain these loads without experiencing the excessive settlement or failure. Geotechnical engineers use this deep soil mixing. Thus, deep soil mixing is nothing but DSM, deep soil mixing, to determine the shear strengths and overall stability. Especially in pile foundations. Pile foundations are used for heavy structures or in regions where the soil surface is weak. Piles are driven deep into the ground to transfer loads to stronger soil layers. In such cases, this deep soil mixing is crucial for evaluating the shear strength of different soil layers at varying depths. Here also we may observe different depths having different types of soil conditions. So those each variety having their own kind of and also their different kinds of surroundings are also there. These are all the parameters we have to understand once we choose these deep soil mixing as a ground improvement techniques. This method helps engineers to determine the friction between the pile and the surrounding soil, which directly impact the load bearing capacity of the pile foundation without accurately knowing the shear strength. there is a risk of foundation failure leading to uneven settlement or collapse. In shallow foundations such as spread footings or mat footings, we may consider these rely on the soil nearby the surface to carry structural loads. In this, deep soil mixing is employed to assess the shear strength of the surface soil, which is critical in determining the bearing capacity of the soil. Bearing capacity of the foundation. If the shear strength is too low, the foundation may fail by shearing throughout the shear, causing settlement or tilting of the building. By conducting shear tests, engineers can adjust the size and depth of the foundation to prevent such type of failures. Moving to the retaining walls type of structures. So here retaining walls are used to hold back soil or rock from building or road. The stability of a retaining wall depending upon the shear strength of the backfill soil. The soil behind the wall. Backfill of soil is nothing but the soil behind the wall. This deep soil mixing helps determine whether the backfill soil has enough strength to resist lateral forces. If the backfill soil is weak and fails, the wall may collapse, leading to the soil sliding and potential damage to the structures or roads. By using DSM to analyze the soil shear strength, engineers can design retaining walls with appropriate safety factors. These are the factors involved in this type of building foundations. We may observe in marine infrastructure. So, in marine infrastructure prevents unique challenges due to the interaction of the structures with water and submerged soils. In this, deep soil mixing plays a key role in ensuring that marine structures are stable and they are able to withstand various forces including wave action and currents. Here in marine structures, the wave actions and the different conditions are there. So, in this offshore wind turbines, the foundation of offshore wind turbines are subjected to significant environmental loads. They are including wind, waves and currents. These environmental loads are varying time to time and season to season. These kind of heavy fluctuations we may observe in this marine infrastructure. So, to ensure this stability of these turbines using these deep soil mixing is used to assess the shear strength of the seabed soil, whether the foundation monopile and jacket or gravity based will be installed. Engineers use this information to design foundation then can resist the lateral forces and also prevents there also sliding and tilting. These are going to prevent, which would compromise the turbine's operation and safety. In backwaters and jetties, these backwaters and jetties are structures designed to protect harbors, coastlines and offshore facilities from the impact of waves. For these structures to remain stable, the shear strength of seabed soil must be known, as these foundations must resist lateral forces from water movement also. In this, deep soil mixing is used to evaluate the soil's ability to withstand the pressure exerted by the waves and currents. If the seabed soils lack significant shear strength, structure may fail, leading to erosion and also instability and collapse. In underwater tunnels like subsea tunnels, like those used for the transportation or utilities, are built through these kind of seabed. During the construction process, we are choosing these deep soil mixing is employed to assess the shear strength of the soil surrounding to the tunnel to ensure that it can be support the loads from tunnel itself and overlying the water pressure. So, if the soil is too weak, tunnel operations may lead to the soil collapse or excessive deformation, and also the integrity of the soils. It may affect the workers also. Coming to the transportation infrastructure point of view, in transportation projects like highway abutments and stability of the soils, railways, bridges is critical for safe and long-term functioning of the infrastructure. In this, DSM is applied to evaluate the soil shear strength in these projects, helping engineers design foundations and abutments that are resistant to failure. In road and railway abutments, those abutments are raised sections of earth that support roads and railways, often built over soft or unstable ground. This deep soil mixing is used to analyze the shear strength of soil beneath and within the abutment to ensure that it can be support the weight of the traffic without sliding or failing. So poor shear strength can lead to the abutment instability, causing roads or railways to settle or even collapse under highway loads. So bridge foundation. The foundations of bridges are critical for their stability. In terms of stability, especially built over rivers on soft soils. So in these piers, here different types of structures are there. They are pier, embankments. They are going to support the bridge deck. They are going to support the bridge deck. They are going to support the bridge deck. Must transfer the loads to the ground without excessive movement. So in that particular such type, we are going to choose these deep soil mixing technique as a ground improvement techniques. So it is used to determine the shear strength of the soil around the foundations to ensure the resistant vertical and horizontal forces from the bridge weights and external factors such as water currents. So insufficient shear strength could lead to the foundation settlement and tilting or even bridge collapse. Moving to the earth dams or levees. In earth dams are used for flood control and water storage. Their stability depend upon the shear strength of the soil used to build them, as well underlining the foundation soil. These deep soil mixing help assess whether the soil is strong enough to withstand the forces exerted by the water behind the dam. So this failure accounted for the low shear strength could lead to these kind of flooding and significant economic and environmental damage. Like that, we are going to understand these kind of deep soil mixing. So in these deep soil mixing, we are going to understand in these different types of ridges and systems. So like this, we are understanding these deep soil mixing in under various different conditions. So thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.